How soon will artificial general intelligence, or AGI for short, that can think and learn like human actually arrive? Experts like Elon Musk, Demis Hassabis, or Sam Altman say by 2030. But what about your prediction? That's right, you can't predict without enough information. In this video, you will uncover the exact blocks of AGI, equipping you to make your own call on when this game-changing technology will arrive. By the end of this video, you won't just understand the AGI, you will be able to challenge the experts and shape your own vision of the future. Plus, as you stay informed in development of this area, you will be able to update your own prediction about when AGI might actually arrive. Alright, let's start with basic.
If we want to build an AI that truly thinks like a human, we need a brain, or at least a digital version of one. This is where cognitive architecture comes in. Think of it as the blueprint for an AI's mind. We're not just talking about raw processing power. We're talking about creating a structure that can simulate the intricate web of processes that make up human cognition. That includes things like memory, attention, learning, and decision-making. All those complex mental functions we often take for granted, but are incredibly challenging to replicate in a machine. Current AI models, even the most advanced like GPT-3, excel at pattern recognition. They can sift through massive data sets, find statistical correlations, and generate human-like text or even code. But here's the catch: they don't actually understand the meaning behind the words they use. Their ability to reason about the world is still quite limited. To achieve AGI, we need an architecture that goes beyond mere pattern recognition. It must enable a deeper understanding of concepts, relationships, and the unpredictable, messy nature of the real world. Researchers are exploring various approaches, including systems inspired by the human brain structure or neural networks that can learn and adapt their own internal architecture over time. Companies like OpenAI and Google are leading the charge with models like GPT-4 and Pathways, pushing the boundaries of what AI can achieve. But even with these cutting-edge advancements, we're still far from replicating the full complexity of the human mind.
It's a bit like trying to build a skyscraper when we just only figure out how to make bricks. Okay, let's say we have cracked the code on cognitive architecture.
We've built an AI with a brain that's theoretically capable of human-level thought. Here's the next hurdle: learning and memory. Humans are incredible learners. We start with very little innate knowledge. And through observation, interaction, and trial and error, we build up a vast understanding of the world around us. We learn throughout our entire lives, constantly updating our mental models based on new experiences. AGI needs to be able to do the same. And I don't just mean memorizing facts and figures. True learning involves understanding context, making connections between different pieces of information, and using past experiences to inform future decisions. Think about how you learn a new skill, like playing an instrument or speaking a new language. It takes time, practice, and the ability to adapt your approach based on feedback. AGI needs to be able to do all of that and more. The good news is we're seeing some promising developments in areas like deep learning and reinforcement learning, where AI agents can learn to perform complex tasks through trial and error, much like humans do. Advanced models like transformers are pushing the boundaries of how much information AI can process and retain, allowing them to generate incredibly realistic text, translate languages with remarkable accuracy, and even write different kinds of creative content. But there's a difference between short-term memory, like remembering a phone number long enough to dial it, and long-term memory, like recalling childhood events or the rules of grammar. AGI needs both. It needs to be able to access and retrieve relevant information from a vast storehouse of knowledge, just like our brains do. This means developing new ways to store and organize information, as well as algorithms that can efficiently search and retrieve that information when needed. Here's the thing about us humans. We're really good at reading between the lines. We understand context, we infer meaning from subtle cues, and we rely on a whole lot of unspoken assumptions about how the world works. This common sense is something that even the most advanced AI systems struggle with. You can feed an AI all the data in the world, but it won't magically develop the same kind of intuitive understanding that humans have. For example, you can tell an AI that the trophy doesn't fit in the suitcase because it's too small, and it might be able to understand the words individually. But it takes a deeper level of reasoning to infer that it's the suitcase that's too small, not the trophy. We just get that intuitively. AGI needs that same level of common sense. It needs to be able to understand the world in a way that's less about crunching numbers and more about grasping the underlying concepts and relationships that govern how things work. This means teaching AI not just what things are, but why they are that way. It means developing systems that can reason about cause and effect, understand the motivations behind human actions, and make judgments based on incomplete information. It's a tall order, but there are some exciting avenues of research. For instance, some researchers are trying to build AI systems that learn through interaction and experience, much like children do. Others are exploring the use of symbolic reasoning, where AI systems manipulate abstract symbols to represent knowledge and make inferences. We're still in the early stages, but the pursuit of common sense reasoning in AI is crucial if we want to create machines that can truly understand and navigate the complexities of the human world. It's the kind of challenge that keeps AI researchers up at night, and for good reason. Today's AI systems are pretty good at specializing. You've got your chess-playing AIs, your medical diagnosis AIs, your self-driving car AIs, each trained on massive data sets specific to their domain. But AGI can't be a one-trick pony. It needs to be a jack of all trades, capable of taking what it learns in one context and applying it to something completely different. Think about it. You learn how to ride a bike, and that knowledge helps you understand balance and coordination in other areas of your life. You learn a new language, and suddenly you're better at understanding grammar in your native tongue. Humans are constantly transferring knowledge and skills between domains, and it's a big part of what makes us such adaptable learners. AGI needs that same flexibility. It needs to be able to recognize patterns and apply principles across different fields, even those it hasn't been specifically trained on. This is where things like transfer learning and meta-learning come into play. Transfer learning is all about teaching AI to apply knowledge from one task to another, like using the knowledge gained from training on millions of images to identify objects in a totally new set of images. Meta-learning takes it a step further, aiming to teach AI how to learn more effectively in general, so it can adapt to new tasks and environments more quickly. Imagine an AI that can learn how to learn a new language in a matter of hours based on its experience learning previous languages. That's the kind of generalization ability we're talking about. It's a complex problem, but the potential is huge. An AI that can generalize its knowledge could revolutionize fields like scientific discovery, engineering, and creative problem solving. It's about creating machines that aren't just good at one thing, but can adapt and thrive in a world where change is the only constant. Okay, picture this. You've got an AI that's smart, it's learned a ton, and it can even reason about the world around it. Sounds pretty good, right? But here's the catch. It still needs us humans to hold its hand every step of the way. We have to feed it the right data, program it for specific tasks, and basically tell it what to do all the time. That's not AGI, that's just a really advanced tool. True AGI needs to be more like, well, us. It needs to be autonomous, capable of setting its own goals, making its own decisions, and adapting to new situations without constant human intervention. Think about how you navigate a new city or learn a new skill on the fly. You don't need someone to program every decision into your brain, right? You observe, you experiment, you learn from your mistakes, and you adjust your approach accordingly. AGI needs to be able to do the same. It needs to be able to operate in the real world with all its messiness and unpredictability and figure things out on its own. This means developing AI systems that are inherently curious, that are driven to explore and learn about their environment without explicit instructions. It means creating AI that's not afraid to make mistakes, but can learn from those mistakes and become more resilient over time. We're seeing some early examples of this kind of autonomous behavior in areas like robotics, where robots are learning to navigate complex environments and perform tasks without human intervention. Self-driving cars are another example, where AI systems are constantly learning and adapting to changing road conditions and traffic patterns. But true autonomy, the kind that would characterize AGI, requires a level of flexibility and adaptability that current systems haven't quite mastered yet. It's about building AI that can truly think for itself, learn from its experiences, and make decisions that align with its goals. Here's a question that's a bit more philosophical. Does AGI need to have feelings? I mean, we humans are emotional beings. Our emotions influence our thoughts, our decisions, and how we interact with the world. So, if we want to create AI that's truly intelligent, does it need to be able to understand and respond to emotions? It's a complex question, and there's no easy answer. On the one hand, emotions can be messy and unpredictable. They can sometimes lead to irrational behavior, and it's not clear that we want AI to be susceptible to the same emotional biases that humans are. On the other hand, emotions play a crucial role in human communication and social interaction. We use emotions to build trust, express empathy, and navigate complex social situations. An AI that doesn't understand emotions might struggle to interact with humans in a natural and meaningful way. So where do we draw the line? Do we try to build AI that feels emotions, or do we focus on creating AI that can understand and respond to emotions without necessarily experiencing them itself? Researchers are exploring both approaches. Some are working on developing AI systems that can recognize and respond to human emotions through facial expressions, tone of voice, and body language. Others are developing AI systems that can generate their own emotional responses, even if they don't experience those emotions in the same way humans do. It's a fascinating and rapidly evolving field, and it raises all sorts of ethical and philosophical questions about the nature of intelligence and consciousness. But one thing's for sure, if we want to create AI that can truly understand and interact with humans on a deeper level, emotional intelligence is going to be a key ingredient. We've talked about building an AI that's smart, adaptable, and maybe even a little bit emotionally aware. But here's the thing about powerful technology, it's a double-edged sword. Fire can keep us warm and cook our food, but it can also burn down our houses. The same goes for AGI. In the right hands, it has the potential to solve some of humanity's biggest challenges, but in the wrong hands or even just poorly designed, it could pose serious risks. Imagine an AGI that's tasked with optimizing for a particular goal, like reducing carbon emissions, but it does so in a way that's harmful to humans, like shutting down all industrial activity without considering the consequences. Or an AGI that's designed to be a super efficient financial trader, but ends up crashing the global economy because it wasn't programmed to consider the broader social impact of its actions. These aren't just sci-fi scenarios, they're real concerns that we need to address now, before AGI becomes a reality. That's why ethics and safety are arguably the most important ingredients in the whole AGI equation. We need to ensure that AGI is aligned with human values, that it understands and respects our ethical principles, and that it's designed to operate safely within the bounds of human society. This means building in safeguards and control mechanisms, developing robust testing and evaluation procedures, and fostering open and transparent dialogue about the potential risks and benefits of AGI. It also means thinking deeply about the ethical implications of creating machines that could one day surpass human intelligence. Do we treat them as tools or as something more? What rights and responsibilities do we owe to them and they to us? These are big questions, and there are no easy answers. But they are questions we need to be asking ourselves now, because the future of AI is ultimately up to us to shape. Okay, we've covered a lot of ground here. We've talked about cognitive architecture, learning, common sense reasoning, generalization, autonomy, emotional intelligence, and even the ethical implications of AGI. But here's the thing about intelligence. Whether it's artificial or biological, it's not just about individual components. It's about how those components work together. Think about your own brain for a second. You've got different regions responsible for different functions, but they don't operate in isolation. They're constantly communicating, sharing information, and working in concert to produce a seamless experience of thought, feeling, and action. AGI needs to achieve that same level of integration and synergy. It's not enough to just have an AI that's good at learning, or good at reasoning, or good at understanding emotions. It needs to be able to do all of those things simultaneously, seamlessly, weaving them together into a coherent whole. This is where things get really tricky. Integrating all of these different aspects of intelligence into a single unified system is a monumental challenge. It's like trying to conduct an orchestra where each musician is playing a different instrument in a different key and at a different tempo. But instead of musical instruments, we're talking about complex algorithms, neural networks, and computational models. Achieving synergy between these different components will require breakthroughs in our understanding of intelligence itself, as well as innovative approaches to software engineering, computer science, and maybe even some fields we haven't even invented yet. It's a challenge that will push the boundaries of human ingenuity, but the potential payoff is enormous. Because when we crack the code of integration and synergy, we won't just be creating artificial intelligence. We'll be unlocking new frontiers of understanding about the very nature of thought itself. We've talked about the software side of AGI, but let's not forget about the hardware. All those mind-blowing algorithms and neural networks, They need serious computing power to run. We're talking about crunching numbers on a scale that makes your laptop look like an abacus. Current AI models are already pushing the limits of what's possible with traditional computing, and AGI is going to be even more demanding. Think about training a model that's as complex as the human brain. We're talking about trillions of connections and calculations happening simultaneously. To handle that kind of workload, we need a new generation of hardware specifically designed for the unique demands of AI. That means faster processors, more memory, and more efficient ways to move data around. We are talking about things like GPUs, which are specialized chips originally designed for graphics processing, but are now used extensively in AI. Then there are TPUs, or tensor processing units, which are custom designed by Google specifically for machine learning applications. And we're just scratching the surface. Companies like Nvidia, Intel, and AMD are in a constant race to develop even faster, more powerful chips that can handle the ever-increasing demands of AI. But it's not just about raw processing power. We also need to think about things like memory bandwidth, data storage, and energy efficiency. Because training and running these massive AI models requires a lot of juice. We're talking about data centers that consume as much energy as small cities. So as we develop the hardware for AGI, we also need to think about how to make it sustainable and energy efficient. Let's talk about the elephant in the room, the energy consumption of AI. Training a single large language model can consume more electricity than hundreds of homes use in a year. And as AI models get more complex, the energy demands only increase. This raises some serious sustainability concerns. If we're not careful, the pursuit of AGI could come at a significant cost to the environment. But it doesn't have to be this way. Researchers and engineers are working on developing more energy-efficient AI algorithms and hardware. One approach is to use techniques like model compression and pruning, which reduce the size and complexity of AI models without sacrificing too much performance. Another approach is to develop new hardware architectures that are inherently more energy efficient. For example, some researchers are exploring the use of neuromorphic computing, which aims to mimic the energy efficiency of the human brain. And then there's the potential of renewable energy sources to power the data centers where these AI models are trained and run. Companies like Google and Facebook are already making strides in this area, powering their data centers with solar and wind energy. The bottom line is that while the energy consumption of AI is a real concern, it's a solvable problem. By investing in research, innovation, and responsible development practices, we can create a future where AGI benefits humanity without harming the planet. It's about finding the right balance between technological progress and environmental stewardship. So there you have it, the key ingredients of AGI. From cognitive architecture and learning to emotional intelligence and ethical considerations, we've covered a lot of ground. As you've seen, there's been incredible progress in AI, but AGI is a whole other ballgame. It's not just about making AI better. It's about fundamentally rethinking what AI is and what it's capable of. Some experts, like Elon Musk, predict AGI by 2028. Based on what you've seen, do you think we're that close? Or is it still a distant goal? After watching this video, you're equipped to make your own informed predictions. Pay attention to the advancements in these key areas. Each breakthrough, each milestone brings us closer to understanding the potential and the challenges of AGI. The future of intelligence is being written right now, and it's up to all of us to stay informed, engaged, and to think critically about the role we want AI to play in our world.